Now, an important process in memory is that of forgetting. And of course, a good question is why exactly do we forget? What is happening that is leading us to become unable to retrieve something that we've processed and we've put in memory? Now, generally speaking, there are two main explanations. One is known as the memory decay hypothesis. And really, the idea is that forgetting occurs because time passes. And as time passes, your memories just slowly fade. Much like color over time fades, the same is true of your memory. And it's just a normal process that is ongoing all the time. And so any item in your memory that you're not, you don't recall, you don't practice, you don't study over a period of time will just spontaneously lose strength and sort of fade and fade and fade until it just automatically decays and disappears from memory. A different hypothesis instead, typically referred to as interference theory, is that it's not it's not quite that information decays or memory traces decay. You forget because uh, there's interference in your memory. So old items you've studied or new items you study interfere with each other and lead you to forget items that you might have memorized. Now notice that while the memory decay hypothesis is about um, is about disappearance of a memory trace, interference theory is really about displacement. It's displacement of one memory trace by another memory trace. Now, generally speaking, there are two main types of interferences that can happen. And we refer to the first one as proactive interference. Now, this is when information um, that you study now is going to later affect something else that you try to memorize. So in the case of this example, whatever materials A you're studying now risk interfering proactively, so towards the future, risk of interfering with future things that you want to learn. So when things you already know, you've already learned, interfere with new things you're learning, that is referred to as proactive interference. Conversely, when information that you learn now leads you to interfere and then therefore forget information that you studied earlier, that is known as retroactive interference. So what you study, the new elements you study, interfere with the old ones you already knew. Now, you might remember the experiment by Peterson and Peterson in 1959, where they were trying to measure how long short-term memory could last in the absence of rehearsal. And you'll remember that they gave trigrams to participants that they'd have to encode, and then right after they'd have to count backwards by 3. This was to prevent them from rehearsing. And Peterson found out that short-term memory under this circumstance lasts somewhere around 15 seconds. Now, they interpreted this as a case of decay. If you don't rehearse something in memory, it kind of slowly fades, and then it's gone. Now, Kettle and Underwood, on the other hand, reanalyzed the data, and what they noticed is that at the beginning, participants could hold on to those memories to those trigrams for just about 15 seconds or close to that. But then they got progressively worse at remembering these trigrams. So, the first trigram, they do 15 seconds, the second trigram, 15 seconds. But slowly over time, as they would do multiple trials, the later trials would on average be worse. So they would be able to recall correctly the trigrams less times than in the first few trials. And so they interpreted this as a form of interference. So sure, perhaps there's fading going on, which explains the 15 seconds. Although in fairness, you could explain that too as interference, because you have something in your mind, it gets interfered with by by the numbers that you're counting backwards, and therefore you lose that. Whichever the case may be, to explain those 15 seconds, whether it's just that stuff decays if you don't practice it, or it gets interfered by the distractor task, the counting backwards by 3, this reanalysis of the data shows that as you encode it in your memory more and more trigrams, right? So the first trial, maybe you hear XZT, and you remember it. Then the second trial, you get another trigram. And then the third trial, another trigram. The trigrams from previous trials are now confusing you and interfering with your recollection of the new trigram. Let me give you an example of somebody who studied this specifically. And this is the case of Wickens. In fact, a lot of studies by Wickens and colleagues all tackled at this particular point. In fact, he was interested in exactly proactive interference. So when information you've already studied in the past is interfering with new information, the acquisition of new information and the recalling of new information. Here's what they did. They gave participants a number of trigrams, which they would have to recall. And so you'd first get a trigram. They had two different groups, a control and an experimental, but I'll get to it in a moment. Turns out, the first time you get TSK and sort of you remember it well. And then sort of the more trigrams you get, the worse you perform. So the first trial you do all right, the second trial a little worse, the third trial a little worse, et cetera, et cetera. And the idea here is that once you get to the third trigram, the older trigrams are sort of interfering with your recollection of the new one. Proactive interference. The information you already know and you already encoded is interfering with the new information. But here's the clever trick. Now, the control group got another trigram that was consonants, just like the ones we've just seen. And of course, their performance keeps, their performance is still pretty bad. The interesting thing is that the experimental group, on the other hand, instead of getting another consonant trigram, got a digits trigram, so a trigram made of numbers. And turns out participants now are instantly better. And this is known as release from proactive interference. The new trigram is no longer interfered by the old ones because it comes from a completely different group. Letters, consonants, are not going to interfere proactively with your ability to encode and to recall a digits trigram. So in the sense, there isn't a conflict between the same kind of information. So definitely showing that interference plays a role in short-term memory. Now, in further studies, it was later demonstrated that you can actually get this also with other kinds of interference. For example, semantic-based proactive interference. So you can give, you can replace these trigrams with, 3 lists of foods. So you might have, a list of, let's say, fruits, okay? 3 types of fruits, and you'd have to remember them, then 3 types of fruits, and you'd have to remember them, 3 types of groups of fruits, et cetera, et cetera, et cetera. And as you accumulate fruits, you sort of get confused with, oh my God, was banana this time or was banana the time before? I forget now. So you're getting proactive interference. If suddenly, so control group, you give them yet again another 3 words from the list of fruits, they will keep getting interference, so performance will drop. If instead, to the experimental group, you give them now a list of something else, tools, suddenly they do very well. Of course, these tools don't get interfered by, right, are not semantically close to fruits. So the stuff you've encoded in the past doesn't proactively interfere anymore with the new list because they're separate enough, but they don't cause interference. And one interesting small aspect of this, but we'll get to it later on, is that this is also telling you that long-term memory is probably organized in a semantic fashion. Because see, typically we believe that the proactive interference is items in your long-term memory, so things you already know, are interfering with new items coming into your short-term memory. And so The fact that you can get interference on the basis of whether something is a word from a list of fruits or a word from a list of tools means that long-term memory is probably organized in a semantic fashion. But we're going to get to this later on.